let us go through the first one. It says a square with a diagonal of 9 square root of 2. So that means, yeah.
It's a 45, 45, 90.
It's going to be a 45, 45, 90, yeah. Just laughing because that's the one that you shouted across the room. Yeah. No, once again, I'm okay with you helping the people in your group. I just don't want stuff happening across the room. Does that make sense? Oh, no, not really. Okay. All right. So we have a square, and just like EJ said, when we cross this, that's going to turn into a 45, 45, 90 triangle. With a hypotenuse of 9 square root of 2. Remember, a 45, 45, 90 triangle, we would have S, S, and this would be S square root of 2. Well, if this is S square root of 2, what does my S have to be? What does my S have to be? Someone besides EJ, he got the last one. Sizer. 9. It has to be 9. So that makes all of our S's 9. So this one would be 9. This one would be 9. And so the area would just be 9 times 9, which equals 81. So the correct answer was, what I have, B. B, 81. All right, the next one is a rectangle with base 12 and a diagonal of 13. So let's go ahead and draw that. So we have a 12. And we have a 13. How do I find that missing length? How do I find that missing length? Krupa? We could do a squared plus c squared, or a squared plus b squared equals c squared. What else could we have done? Yeah?
Just know it was 5 because it was a Pythagorean triple.
Know that it's a Pythagorean triple. Do I care which way you do it? No. Pythagorean triple is probably a little faster. Probably a little faster because we can just go ahead and say, okay, that's 5 because it's a Pythagorean triple. Or we could have did a squared plus b squared equals c squared. Either way, we should have came out with 5 being that, which means our area is 12 times 5, which would equal 60. And if we had units, it'd be something like 60 units squared or centimeters squared or feet squared or whatever squared we have. That is the definition of area. All right, questions on either one of those two? Okay, questions from the homework. Yeah. The last one. Let me see if I even have these accessible. There it is. All right, the very last one, was that the length of the sides of 3 squares one?
Yes.
Okay. So we have the length of 3 squares are S, S plus 1, and S plus 2 respectively. So we have 3 squares. 1, 2, 3. We have one that's S, S plus 1, and an S plus 2. Well, they're squares. So if I have a length of S, I have a width of S. If I have a length of S plus 1, I have a width of S plus 1. And finally, I would have this one being an S plus 2. Well, it says when you add up all of their area, it's 365. So the area of your first square would be S squared. The area of your second one would be S plus 1 times S plus 1. And then the area of your third one would be S plus 2 times S plus 2. When you add all these areas up, it needs to equal 365. Well, S squared is already simplified. Plus, then we'll have S squared plus 2S plus 1. And then we're going to have plus, well, S times S. Remember, just real quick for people that struggle on binomial expansions, just do your S times both items, and then just do your 2 times both items. So we're going to have S times S, which is S squared. S times 2, and then a 2 times S would be plus 4S. And finally, 2 times 2 would be plus 4 equals 365. Well, working our way down, you should end up with actually getting down to S squared plus 2S minus 120 equals 0, which factors into S plus 12 times S minus 10 equaling 0. This one would be S equals a negative 12, which isn't going to work. And another one would be S equals 10, which does work. So you're just going to replace 10 in for each of your S's, and you'll be able to get your areas for all three of them. John?
So it's not 3s squared?
It would be 3s squared plus 6s plus 360, but you can divide everything by 3.
Oh.
Yep. So I skipped a little step in there. You would, if you could see 3 goes into all of it, it's just going to make your life a lot easier. And 3 went into all of them evenly, which reduced. So, like I said, you would actually have 3s squared plus 6s minus 360 would actually be your kind of next step. And then you divide everything by 3 to get what I have there. Jacob, since you asked that question, does that all make sense?
Yeah.
Okay, cool. Any other questions on this one? Okay, other questions from the homework? Yeah. 29. 29 says that we have, so the hard part about 29 is we're talking about 4 rooms. Or I mean 4 walls, sorry. We're talking about 1 room. We're talking about a room that we're looking down at. We're looking down at a room that has a width of 28 feet by 20 feet. And then it says that it has walls that are 8 feet tall. What is the total area of the walls? So it's kind of hard to see this, but especially from this perspective, but we're talking about, we're building walls up like that. That's one of the walls. Can you kind of picture? Oh, you don't see it at all. And see if it comes out this time. There we go. All right, picture that wall that's shooting up. That's that back wall. That's that back wall of it. And we said that the floor was 8 by 28, which means this wall that I marked in red is 28 feet in length. And it says that the walls are each 8 feet tall, so it'd be by 8. Well, we also have a wall here. It's really hard because of the flat surface, but we'll try to make do. This is another wall. Going up, this one would be 8 by 8 feet tall. And there's 4 walls. So you get the area of this one, multiply it by 2 because we have a wall here. And we get the area of this one and multiply it by 2 for here. So it's 4 walls. Does that make more sense? Now it's drawn up. Awesome. So in fact, it'd be 28 times 8, multiply that by 2, and then we plus that 8 times 8 times 2, and that'll be your total areas added together. Other questions? Okay. Then we'll go into today's lesson. Today's lesson is going to be talking about areas of parallelograms and basically just other shapes. So we're going to start with a parallelogram. What is the area of a parallelogram? Yeah?
Is it half times the base 1 plus base 2 times height?
No, you're thinking of a trapezoid, I think. Because a parallelogram is actually one of the easier ones. Yeah?
Base times height.
It's just base times height. And let's talk about why it's just base times height. There's a way to just picture it. So what I'm going to do is I'm going to draw a little dashed line right here. That is actually the height. We'll call this the height. Now, if you look at this little section I'm cutting out basically, if I took that section and cut and paste it right onto the other side, so I'm going to cut and paste that section right here, you're going to see you have a rectangle. So a parallelogram is actually just a rectangle that's slightly tilted. But I could take that tilt and add it to the other side, which makes it just a rectangle. And a rectangle has base times height. So this is the same area as a rectangle. So the area of a parallelogram is going to equal base times height, length times width, however you want to put it. In this terms, I'm going to put it base times height. And that is our area of a parallelogram. But once again, this is something you can figure out on the test if you forget. Just remember, you could take this chunk, put it there, and you have a rectangle. All right, we have two examples. First example says, find the area of the parallelograms shown. Now, the reason why I put it like this, because this one confuses people. This one confuses people because they're just afraid to turn their sheet sideways. If you turn your sheet sideways, this 6 is the base. And this 8 is actually going to be the height of it. And we know it's the height because it has this 90-degree symbol. It looks a little wonky sideways. It almost looks like this wouldn't be a straight line. But if I would cut this off and put it on there, you would have a rectangle. So our base is 6. So when we're doing area equals base times height, that's going to equal, base is our 6. Our height is 8, so it's just 6 times 8, which is 48 units squared, or just whatever you have squared. All right, the next one we have to do a little bit more work. I need to find the height of it. Well, it's a 45-degree triangle, so that's going to be nice and helpful. It's a 45-90 triangle where I have a hypotenuse of 8. How do I list the sides of a 45-degree triangle? Mm-hmm.
Is it S2, S, and S squared? Or not,
That
square root?
That is 60. One of them has a square root in it. Yeah.
It's SS and then S squared.
Oh,
Yep. It's S squared root of 2. So our hypotenuse is going to be our S square root of 2. And our height is going to be our S. So let's do a little side work. If S squared of 2 equals 8, I would divide both sides by square root of 2 and come up with S equals 8 square root of 2. Is 8 over square root of 2 simplified? What do I need to do to simplify it? Oh, can we get some more hands? Jeez. Yeah.
Multiply like the reciprocal of the 2 to like
The top and the bottom. Yeah, so we're just going to multiply top and bottom by square root of 2. That's going to give me 8 square root of 2 over square root of 2 times square root of 2 is 2. So S is actually going to equal 8 divided by 2 is 4 square root of 2. So since this is S, my height is also 4 square root of 2. Height equals 4 square root of 2. That means I have a base and I have a height. So our area is going to equal 10 times 4 square root of 2, which is going to equal 40 square root of 2. I'll just put units squared for the fun of it. All right, so when you have a parallelogram, your job is to find the base and the height, and then you have an area. All right, the very last thing we're going to talk about is area of triangle. What is the area of the triangle? Can someone tell me the area of the triangle? And let's see more than one hand that reluctantly goes in the air. Let's give me some options here. Give me some options. Victoria. Half of base times height. So we all are conditioned to know the area of the triangle for the most part. Area equals half of base times height. But let's take just a second to look at why it's that way. Why is it half of base times height? Well, if we read this really quick, if you look at your bell work, you will note that you can divide a rectangle into 2 triangles. And any rectangle can be divided into 2 triangles, or at least half of it. This means that the resulting triangle will have exactly the area of a rectangle. So the reason why a triangle is half of base times height is it actually is half the size of the rectangle that would form around it. So any triangle you have is half the measure of a rectangle that would consist of all the way around that triangle. That's where that 1/2 comes from. I don't know why everything's just crazy today. All right. That's area of a triangle. All right. So I wanted to put a little more interesting one. So we have find the area of a triangle with sides 5, 5, and 8. This is a common one that people get wrong on tests and on homework. Remember, if you're not sure what to do, at least draw a picture. At the very least, draw a picture. You get a point for a picture. So it says we have a triangle with sides 5, 5, and 8. So let's draw that triangle. And more specifically, what kind of triangle has two sides being the same? Isosceles. So I'm going to draw it like an isosceles triangle where we have 5, and we have 8. Well, I need to have a base times the height. I need half the base times the height. Well, in order to have that, I would need to find the height of this. Well, the important part about being isosceles is the altitude or the height of the triangle is going to cut your base in half. So that means 8 is going to split into a 4 and a 4. Without doing any work, what is the height? What is the height of this? Yeah, 3, because it's probably the one Pythagorean triple everyone knows. 3, 4, 5. This is a 3, 4, 5 triangle. So that is your goal for most of the time, is pulling out this triangle and recognizing that it is, in fact, a 3, 4, 5. So we have a 4 and we have a 5. We should know that this is 3 because it's a Pythagorean triple. If all else fails, just do a squared plus b squared equals c squared. So many of us look at right triangles and know two sides and like, I need to use trig. No, if you know two sides of a triangle and you're looking for a third one, just always go a squared plus b squared equals c squared. In fact, just think that. Look at a triangle and say, can I do a squared plus b squared equals c squared? If you can't, then talk about trig and doing other stuff. All right, so that's going to be 3. So that means our height is 3. That means the area of this triangle is going to equal 1/2 the base, which is 8, times the height, which is 3. Half of 8 is 4. 4 times 3 is going to be 12. They didn't really give me units, so let's just put units squared. All right, the only thing really interesting about number 2 is where the height is located. Too many of us get bogged down in this fact that the height has to run through the middle of the triangle. There are times where this is going to be your height. Your height can be outside the triangle. When we did our altitudes, we said for obtuse triangles, it has to be outside the circle. So this 15 centimeters, even though it's outside of the triangle, is still the height. That is still the height of your triangle. So you don't have to do any work. You know what the base is, and you know what the height is. We'll call this my base. Your base will always be the one that's connected to your height. So the base will always be the one that creates that 90-degree angle to your height. That's important, because don't pick 18 as your base. You won't get the right answer. Your base is always going to be the one that's connected to this 90-degree symbol. And so we know our height. We know our base. So that means the area is going to be 1/2 your base. Like I said, that has to be the 22. And your height is that 15. Half of 22 is 11. 11 times 15. That is going to be, 165. Yeah. And it is centimeters, so I'll do centimeters squared. All right, so be careful on your height and careful which one's your base. Triangles can be upside down too, or sideways. Be aware of which one is your base. Your base will always create that 90-degree angle with your height. All right, example 3, it says, given the area of the following triangle is 60 centimeters squared, solve for the height. This is my example here. This is our base. Bless you. And this is our height. Your height and your base form a 90-degree angle. So in fact, you could have called h your base and h your height. It really doesn't matter in this one. So our base is 8. So remember, area of a triangle equals 1/2 your base times your height. Well, in this case, I know the area is 60. The 1/2 is going to remain. This 8 centimeters is going to be our base. And so we're going to have 1/2 times 8 times that h is going to equal 60. Well, half of 8 is just 4, so we're going to have 60 equals 4 times h. Right, Labib? Let's stay with us. All right, so now all we have to do is divide both sides by 4. And we're going to end up with h equals 15. Know how to go that direction as well. Yes?
Could you also input the multiply both sides by 2 and do 120
Equals 8h. Yep. Yep, all valid, as long as you multiply or dividing both sides on the same thing. All right, the very last thing we're going to talk about is a rhombus. A rhombus. Now, here's the thing about the rhombus. A rhombus is a parallelogram. So you already know the formula for most of our rhombuses we're going to see. Well, since a rhombus is a parallelogram, it's going to follow the same rules as a parallelogram. So if you look back for a parallelogram, it is just base times height. So your area, if you know the altitude, is going to equal base times height, and that's because it's a parallelogram. But remember, a rhombus is a very specific parallelogram. Can someone tell me what makes a rhombus a rhombus? Emma. All sides are congruent. So that's why we have S, 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 and S. So on this drawing, we can make all of our sides congruent as well. Here is another method for coming up with the area of a rhombus. And this one's based upon the fact that you know both diagonals. This one is if you know the base and the altitude. This one is if you know both diagonals. Well, kind of like a triangle. If I draw a rectangle around our rhombus, we're going to notice each of these triangles is half that small rectangle, which means that entire shape, that entire rhombus, is half the size of that rectangle. So in picture form, kind of. If we look at that right there, that is diagonal 1. This length right here would be diagonal 2. Well, the area of that rectangle would be diagonal 1 times diagonal 2. So the rectangle with the rectangle, your area would be diagonal 1 times diagonal 2. But for the rhombus, I need to cut away at all of this excess. And like I said, if you focus on just one of these little squares, you're going to notice that each of these triangles is half of this small rectangle. Half of this small rectangle, half of this small rectangle, half of this small rectangle. So for our rhombus, it's going to be half the area of the rectangle. So area is going to equal half the rectangle, or half of diagonal 1 times diagonal 2.
Is that also the case right now?
You sure? Okay. So in this one, you don't need to know the base or the height. You just need to know both diagonals. So be very careful what information they give you on a problem. If they give you both diagonals, you have to use this half diagonal 1 times diagonal 2. If they give you the altitude, then we're going to do base times height. So let's do this example down here. So just based upon this drawing, it's focusing me towards the diagonals, isn't it? Because they didn't talk anything about the height going between them. So let's focus on the diagonals. We know one diagonal. We have diagonal 1 equals, is it 4 or 8? 8. It'd be 8. All right, let's solve for diagonal 2. Well, one of the properties of a rhombus, where your diagonals intersect at a 90-degree angle, you have to remember that. Diagonals of a rhombus intersect at a 90-degree angle. So we have 4 right triangles. We have 4 right triangles. Let's go ahead and draw one of these right triangles. Where the hypotenuse is 5. The base is 4. We already said that Pythagorean triple is 3, 4, 5. So our missing side is just 3. So that means this is 3. This is 3. That makes our diagonal 2 equal to 6. So our area is going to equal 1/2 8 times 6. Well, half of 8 is 4. 4 times 6 is 24. Did we give units? No, we didn't, so let's just do units squared. All right, let's just recap really quick. Area of a rectangle. Emma. Length times width. Area of a parallelogram. Yes. Base times height, or which is the same thing as length times width, kind of, right? Area of a parallelogram. Yes. Base times height. Area of a triangle. Yep.
Half base times height.
Half base times height. One of the areas of a rhombus. Base times height. What's the other formula for a rhombus? You guys all answered. Jacob. Yep. Half of both of our diagonals multiplied. Know all these formulas. If it helps you, put all the formulas on one card or something. Have a card that has all of them on. But you need to have all these formulas memorized. They just have to be. And you got to practice them enough that you don't get confused between them. It's the difference between you doing really well on this test and really poorly on this upcoming test. It's whether you know the formulas or not. And that really is just how much work you put into this class. How much work you go home and just go through your formulas. So even if it takes going home every night and practicing this for 5 minutes, the more you have these formulas down, the easier life is going to be in this section. All right. The rest of the time is yours. The homework is not that